Hello dear students, welcome to my YouTube channel. Today we are going to discuss about the derivation expression for electrical field along an axial plane, children. What do you mean by dipole, children? Dipole means it is two, children. A dipole which consists of negative charge and the positive charge. Let I write in a diagram, children. The point will be negative charge. Charge is denoted by the letter Q. It will be to the, here I will write the positive charge, children. The length of this dipole will be 2L. Let I consider a point O on the axis of dipole, children. What will happen? Point O means this will be L. The total distance of the dipole is 2L. What is the distance between O to positive charge? It will be L, and negative charge and O, it will be also L. Half of L plus L, it will be 2L, children. Now let I write the positive test charge point P. Here the electrical field will repulse to along this direction. It will be E plus the point P, children, the point P, and it will be also reflects, means it will also repulse at this direction. It will be electrical field of negative, children. Then the distance between the midpoint of the dipole to the point P will be the distance of R, dear children. The R. Let I consider it as R, children. We have to find now E plus. What is E plus? E plus means K times of charge divided by what is the length between the E plus means from here to here, children. It will repulse from the positive to positive. It will be the total length is R. What will be the distance between positive charge to the E plus? It will be R minus L. R minus L. You all know that we have to square it. And what is E minus? It will be K times of charge divided by from here to here. Means this is R. This is R. Means R plus L. R plus L whole square, children. What is the potential? Means the point P, means the test charge of the positive, it will be EP will be equal to E plus minus E minus. Let I consider here, let I take KQ as a common factor, dear children. We have E plus and E minus. We have a common factor as KQ. It becomes, KQ, and it becomes 1 divided by R minus L square minus 1 divided by R plus L whole square, dear children. Let I take the LCM and solve, children. What is the LCM? R minus L whole square into we have a negative sign, so we will put the negative symbol. R plus L whole square. Let me cross multiply. R plus L whole square minus R minus L. R into cross multiply. R minus L whole square, children. K times of charge. Q is charge. What is the A? It is in the form of A plus B whole square. A plus B whole square means A square means R square plus B square means L square plus 2RL. 2RL. Let I write the denominator part here. It is as it is. R minus L whole square minus R plus L whole square. The negative symbol, it is as a negative. Let me consider A minus B. It is the form of A minus B whole square. What is A minus B whole square? Let I open the bracket because there is a negative sign. R square, A square. R square means A square plus B square minus 2 into A into B means 2AB. It is RL. 2RL. See children, what will go to the cancel? Plus R square minus into plus, it will be also R square, and minus R square get cancelled, and plus L square minus L square is going to cancel. What we left? It will happen minus into minus, it will be plus 2RL. Let I write here. Now the equation becomes EP. Let I write here. EP will be equal to, what we have left? K times of charge will be equal to 2RL minus into minus plus 2RL. It will be plus into 4RL divided by, see children, A minus B and A plus B, A minus B whole square. Here there is a whole power square. Now it will happens R square minus L square the whole square, children. And let I take the part EP will be equal to K times of Q. Let I write the 4RL has 2 into 2 R times 2 into 2 into L divided by R square minus L square the whole square, children. Why have I written this? We have a formula of, let I write here, vector P is equals to Q, charge into length of the dipole. For L we will give the vector. Now let I take EP will be equal to K. Let I take R as here, KR into 2 into, I will take the Q as here, Q into 2L divided by, as it is, R square minus L square the whole square. Let I write here, it will be the, see children, R is very greater than the length of the dipole. R is very greater than the length of the dipole, children. R is very greater than length of the dipole. What is the length of the dipole? The length of the dipole is 2L. And the equation becomes EP will be equal to 2KR. What is the vector P is Q into 2L. We have taken this as the common factor, Q into 2L. You can write it as P divided by, C children. Let I write that. Next step I will write, children, R square minus L square the whole square and EP, and the EP will becomes where the R is very greater than the length of the dipole. We can neglect the L, children. We can neglect the L. Let I neglect it by EP is equals to 2 times kr into p vector p into vector p divided by, if I neglect L, what we have left? R square the whole power 2, means it will become R to the power of 4. 2 into 2 according to the theory of indices. 1R get cancelled. What is the remaining? Electrical point P will be equal to 2 times Kp divided by R cube, because 1R is get cancelled and 3R get remain. What we got the equation. This is an expression for electrical field along an axial plane, children. I hope you have understood this class. If you have understood, what you have to do, go and subscribe the YouTube channel and click the bell icon. And if you have liked my teaching, please go and share it to your friends, children. Thank you. Have a nice day.